Now we have the next major topic of division algorithm for polynomials. We had learned in polynomials so many things till now. This is the last topic that you're going to learn. So what is division algorithm for polynomials? So if you have two polynomials, say p of x and g of x, okay, these two are two polynomials such that g of x not equal to 0, it should be not equal to 0, and then there exists two more polynomials such that there is a relation now. So let me name those two polynomials to be q of x and r of x. Okay, you have the two more polynomials here. So I have to get this relation, that is p of x is equal to q of x into g of x plus r of x. See, you have got the relation now, that is p of x is equal to q of x into g of x plus r of x. So what is the condition for finding the degree of r of x? You can find that the degree of r of x is always less than g of x. It should be always less than g of x, and it can be minimum up to 0. Okay, that is the degree of r of x is minimum is equal to 0. That is what you need to just know, that is not a condition here. This much is the condition. It should be always less than the degree of g of x. Okay, this is the division algorithm. Let me explain this. What is it given? So you are given two polynomials, p of x and g of x. By using the division algorithm, you can find out two more polynomials, that is q of x and r of x, such that the degree of r of x is less than g of x. Okay, let me just give an example. Say I need to divide some number. Okay, let me wrap this off. So division of polynomials, you have already learned how to divide two polynomials. The condition for that, the degree of the dividend should be greater than the other one. So let me have some number, that is 3x square, 3x cube plus x square plus 2x plus 5. This I have the dividend now. So I should get also the divisor. Divisor is x square plus 2x plus 1. X square plus 2x plus 1. So how do I divide this and how do I get the conclusion over there? So first of all, I should check that these terms are in the proper order. That is 3, the degree should be 3, 2, 1, 0. Here x raised to 0. So it's all right here, and the same should be here also. Maximum term should be here, going up to the minimum. So now we are asked to divide this polynomial divided by this. Okay, so let me write this. So for doing this, first I need to get some number, that is first term in the quotient. For that I need to divide the first term of this divided by the first term of this, x square, that comes to be 3x. So here it comes to be 3x. So I need to multiply every term of this to 3x and write it here. That is 3x cube plus 3x into 2x comes to be 6x square. 6x square plus 1 into 3x, that is 3x only. Okay. So now you should be subtracting this from the given thing. So I need to change the sign. Instead of subtracting, I am going to add with the inverse. That's it. Okay. This is going to get cancelled. 3x cube minus 3x cube comes to be 0. This is x square minus 6x square. That is minus 5x square. Now here it is 2x minus 3x. That is minus x. Then you have one more plus 5. Okay. So next number you need to get is first term of this divided by the first term of this. That is minus 5x square divided by x square. That comes to be minus 5. So I need to write minus 5 here. Okay, now I do it to multiply every term of this to minus 5 and write it here. So it comes to be minus 5x square plus 2x into minus 5 is minus 10x. You have plus 1 into minus 5, that is minus 5. So for subtracting, I need to just change the sign. This minus becomes plus, this becomes plus, and this also becomes plus. Okay, this is going to be cancelled. Minus 5x square plus 5x square is 0. Minus x plus 10x is 9x. Plus 5 is plus 10. Okay, so let me consider this polynomial. This polynomial is p of x. This polynomial is p of x, and this polynomial was g of x. So what was the statement of division algorithm? You are given two polynomials, p of x and g of x. You can find two more polynomials, q of x and r of x, based on the red given condition. So this becomes q of x. In such a case, this is q of x, and this one becomes the r of x. Okay, so let me write that in proper statement. So this becomes to be 3x cube plus x square plus 2x plus 5. That is p of x. P of x is equal to g of x, that is x square plus 2x plus 1 into, that is q of x again here, that is 3x minus 5. 3x minus 5, this was g of x into q of x. Then you have one remainder term. Remainder term is 9x plus 10. 9x plus 10 is the r of x. Okay, this was a g of x and this was a r of x. So the condition about getting r of x was that it should be the degree of r of x should be always less than g of x. It cannot be equal to that of g of x, because when you divide this, you are going to get only the remainder part. That's what it means. So this was the condition. I have just given the example. This is p of x and g of x. You are going to find q of x and r of x by using the long division method. Okay. The next question here is, you are asked to divide one polynomial by the other. For that, let me take some ordinary example. The example is, divide x raised to 4 minus 5x plus 6 by 2 minus x square. Find q of x and r of x in such case. R of x in that case. This is the case, right? So divide, if I need to divide, I need to use the long division method. I can find that this is 4 and this is 1 and this is x raised to 0. Okay, now let me write that x raised to 4 minus but still I can find out that there is two terms missing, that is x cube and x square terms are missing. So I need to write that in the form of 0x cube plus 0x square minus 5x plus 6. So it comes to be 4, 3, 2, 1, 0. The degree of that term. I need to divide that by 2 minus x square. Instead of writing 2 minus x square, I'll write it as minus x square plus 2. Because I need the first term to be the highest power or the maximum thing. And the smaller terms come later. That's how I'm going to use. So what the first term will be here, that is x raised to 4 first term divided by this first term, that is minus x square. So it becomes minus x square here. It comes to be minus x square. So I need to multiply every term of this by minus x square. So what is going to come here? You have minus x square into minus x square comes to be x raised to 4 plus 2 and minus 2x square, that comes to be minus 2x square. Here I need to write it in the x square column. X square column is here. So I need to write 2 minus 2x square. Okay. Then I need to change the sign. This comes to be minus, this is plus. So the x raised to 4 minus x raised to 4 0. This is 0 minus 2x square plus 2x square. That comes to be 2x square minus 5x plus 6. So the next step is, again you need to take the first term divided by the first term of this. That is 2x square divided by minus x square. That comes to be 2. Minus 2. Because you have a minus sign here. So again you are getting minus 2 here. Okay. So what are you going to get here? This term minus multiplied by minus 2. That is minus of minus is plus 2x square again. 2x square. Later you have 2 and minus 2. That is minus 4. So I need to subtract, that is change the sign and then add. So 6 plus 4 comes to be 10 minus 5x as it is. So this is the remainder that you're going to get here. So I need to find q of x and r of x. So what are the terms q of x and r of x? This is the q of x term, this is the q of x term, and this is the r of x term. That's it. Now you have the example 9. Example 9 is the question. You are asked to find all the zeros of the given polynomial. This is the polynomial, that is 2x raised to 4 minus 3x cube minus 3x square plus 6x minus 2. For that, they are given that root 2 and minus root 2 are the zeros. Two zeros are given. So just by seeing that this is the power of having a maximum power of 4, you can tell that there are 4 zeros for the given polynomial. So you need to find what are those 4 zeros. Okay, now for that you have root 2 and minus root 2 are the zeros. Okay, so if root 2 and minus root 2 are the zeros, then x plus root 2 and x minus root 2 are the factors of p of x. Let me name this to be p of x. Okay, let me more meaningful. I have named this polynomial to be p of x. So if you have a as the zero of any polynomial, then x minus a is a factor of that polynomial based on the factor theorem. So I am using that here. So just by seeing, I can tell that x minus of minus root 2 or x plus root 2 and x minus root 2 are the factors of p of x. Since these two factors are different, so I can tell that the product of these two factors is also the factor. Product of these two factors comes to be x plus root 2 into x minus root 2. That is a plus b into a minus b form, that is a square minus b square, or x square minus 2 is the factor of p of x. Factor of p of x. So now first I need to divide this and get the remaining thing. So it comes to be 2x raised to 4 minus 3x cube minus 3x square plus 6x minus 2, and I need to divide it by x square minus 2. The simpler way, I need to just go on dividing this by this. So 2x raised to 4 divided by x square comes to be 2x square. I'm not going to do the lengthy method again and again. So just going on writing here 2x raised to 4. So minus 2x into minus 2x into plus 2x square comes to be minus 4x square. So since it's coming to x square term, I'm writing here. I need to subtract, I need to change the sign for that. So this comes to be 0 and this is minus 3x square plus 4x square, that is x square term. I need to bring this down now because that is the maximum power I have. Minus 3x cube plus x square plus 6x. That minus 2 I leave it later. So now you have maximum power is this. So minus 3x cube divided by x square comes to be minus 3x. So you have minus 3x cube here because you have multiplied minus 3x by x cube, and you have minus 2 and minus 6x minus 3x, that comes to be minus of minus is plus 6x comes here. So these two are going to get cancelled because they are going to change the sign. This is going to be cancelled. Now you have x square minus 2. That is, however, 1 plus 1, that comes to be x square minus 2, that comes to be 0. Therefore 0 is a remainder. So you can tell that this polynomial p of x is equal to x square minus 2 into 2x square minus 3x plus 1, and the remainder is 0. I can just leave it like that. That means that these two are the factors of p of x. This factor we have already got that they are the zeros. So I need to just neglect that part. You have the both zeros already ready with you. So you need to take only this term such that you get the two more zeros over there. So I need to factorize that. That comes to be 2x square minus 3x plus 1. For factorizing and getting the number, I need to get the equate it to 0. For this now I need to split the middle term. I have the sum to be minus 3, and the product is 1 into 2. Product is 2. So I need to get two numbers like that. So it comes to be 1 and 2. Since product is negative and sum is positive, both needs to be negative. So it comes to be minus 1 and minus 2. Since the x square term has 2 as the coefficient, I cannot directly write that. I need to split and then find out. That comes to be 2x square minus x minus 2x plus 1 is equal to 0. I'll wrap up this. Okay, now you have x common first. X common, you have then 2x minus 1. Now I'll take minus 1 common such that I'll get 2x minus 1 again as one of the factors. Otherwise it becomes difficult for me to factorize it so easily. This comes to be x minus 1 and 2x minus 1 is equal to 0. Then both of them should be equal to 0, right? They should be equal to 0. 2x minus 1 should also be equal to 0. X is equal to 1. 2x is equal to 1. X is equal to half. So these two are the zeros. Therefore the zeros of the polynomial, that is p of x, is 1, half, root 2 and minus root 2. Okay, these four are the zeros of the given polynomial p of x. So first I found out using factor theorem that x square minus 2 is a factor of p of x by taking these two as factors, that is x square plus 2 and x plus root 2 and x minus root 2 to the two factors. Then you have already using the long division method, I did the long division, and that comes to be, remainder comes to be 0 because it is a factor. We know that already. If it was not 0, you need to just check it again how it has not come 0, because it is already given that it is zeros. So just by using the division algorithm of polynomials, so I wrote that p of x is equal to g of x into q of x, and r of x is 0, so I just neglected that. So I got this. This was the term. You have two factors for p of x, but this term you have already got, and two zeros based on that term comes to be root 2 and minus root 2. So I am just leaving that term and taking this term for further factorization, finding the other zeros. So you have 2x square minus 3x plus 1, and going on factorizing you get x is equal to 1 and x is equal to half to be the zeros of polynomial p of x. Now we are going to start with exercise 2.3. The first question, so first subdivision. The first question is you are asked to divide p of x divided by g of x and find the quotient q of x and r of x. For that we need to use the long division method. So I am going to use that long division method. This comes to be x cube minus 3x square plus 5x minus 3. You are going to divide it by this. This is x square minus 2. Okay. So now the first term here will be x cube the first term of this divided by the first term of this, that is x cube divided by x square, that is x. So I need to multiply x here. Now it comes to be x square into x is x cube. Then you have minus 2 into x comes to be minus 2x. I need to write it in the column of x terms. So while subtracting, now I need to change the sign. This comes to be 0. This will get cancelled. Now this is 5x minus plus 2x, that is 7x. Now you have minus 3x square. I'll bring it down here. Okay, minus 3, let it be there itself. So now I need to divide the first term of this divided by the first term of this. That is minus 3x square divided by x square is minus 3. Minus 3x square divided by x square is minus 3. So I need to multiply that. Minus 3 into x square comes to minus x square. Then you have minus 2 and minus 3. That comes to be 6. So you have minus 3 here, right? So I need to change the sign now while subtracting. This becomes plus and this becomes minus. This comes to be 7x minus 9. So from this you can understand that this is one polynomial and this is another polynomial that we obtained by doing the long division method. This polynomial is q of x, or what you call it as a quotient. Okay. Then this term is the remainder, or that is r of x, remainder. Okay. This is the second subdivision. You have p of x to be given as x raised to 4 minus 3x square plus 4x plus 5, and g of x to be written like this. Okay. For that, first I need to take the long division, right? That is the only thing I need to do in this question. So x raised to 4. There is one x cube term missing. I should write it to be 0x cube. And you have some minus 3x square plus 4x plus 5. And you have to write this in the proper order. You have x square, x term should come in the second, so that it becomes easy for me to multiply and write it in the proper column here. Otherwise, it will get mixed up. Okay, this comes to be x square minus x plus 1. Now, the first term here is x raised to 4 divided by x square. That is x square. So this is x raised to 4. X square into x square is x raised to 4. You have minus x into x square, that is minus x cube. You have plus 1 into x square comes to be plus x square. Okay. So now I need to subtract. For that I need to add it to the opposite. Okay. So this becomes 0. This is x cube. Then you have minus 3 minus 1, that is minus 4x square, and 1 4x here. Okay. Now the next term that should come here is the first term of this divided with the first term of this. This is x cube and this is x square. X cube divided by x square comes to be x. So x square plus x. So I need to multiply this. X square into x is x cube. You have minus x into x is, that is minus x square. And you have plus 1 plus x into x is again 1x. Okay, I need to change the sign and then add instead of subtracting. You have minus 4x square plus x square, that is minus 3x square, and you have 4x minus x, that comes to be 3x. You have 5, right? I'll bring it down. Okay. Now I need to divide it. 3 minus 3x square divided by x square. That is the first term of this divided the first term of this. That comes to be minus 3, and you have minus 3x square here. However, you'll get. Then you have minus x into minus 3, that comes to be plus 3x. Then you have 1 into minus 3, that comes to be minus 3. I need to change the sign. This becomes plus, this becomes minus, this becomes plus. So minus 3x square plus 3x square comes to be 0. 3x minus 3x is 0. You have 5 plus 3, that is 8. 8 is the remainder, or I can tell to be it as r of x. And this term that comes to be here as the quotient is q of x, such that it follows the division algorithm for polynomials. Okay. Next we'll move on to the second question. The second question of this exercise, here you are asked to check whether the first polynomial is the factor of the bigger polynomial given here. So how do you need to find out this? Is by dividing this by this, or using the long division method, that is 2 raised to 4, 2t raised to 4 plus, this is in the proper order, right? 4, 3, 2, 1, 0. I need not worry. Just go on copying that. This comes to be so much. I need to check whether it is proper. Otherwise, my answer will go wrong. Okay. This is t square minus 3. Okay. The first term that should be coming here is 2t raised to 4 divided by t square. That is 2t square. Here the question is, you need to find out whether this is a factor of this. That means that if you get the remainder to be 0, that means that the first one is a factor of the second polynomial. That is the thing you need to find out. The remainder is more important than the quotient in this case. So you can just go on doing this. This is t square into 2t square is 2t raised to 4. You have minus 3 into 2t square, that is 6t square, that comes in this column. That is, oh, you're getting minus, right? Yeah, minus 6t square. Now I need to change the sign. This is however cancelling. This is going to be plus. This is minus 2t square and plus 6t square, that is 4t square, and bringing this down 3t cube, and you have minus 9t. Okay. Now the next term is 3t cube divided by t square, that is 3t cube divided by t square, that comes to be 3t. 3t I need to write here. So just multiply this, it comes to be 3t cube here, and minus 3 into 3t, that is minus 9t. These two are going to be cancelled. Because they are same, I can just write it instead of changing the sign and writing all those things. Now we have 4t square and minus 12. Now 4t square divided by t square is 4. So I need to write 4 here. Now I need to multiply this. 4 into t square is 4t square. And you have minus 3 and 4, that is minus 12. They are same, right? If you subtract, however, it's going to be equal instead of just making this. Okay. So you can just conclude that this is the factor, that is t square minus 3 is a factor of 2t raised to 4 plus 3t square minus 2t square minus 9t minus 12, because you have the remainder to be 0, or I can write it as p of x is equal to g of x into q of x plus z r of x, where r of x is 0. That means that r of x is equal to 0, then q of x and g of x are factors of p of x. This is just a meaning of that. I just wrote a general statement of why I have taken that thing. So now we'll move on to the second subdivision of the second question. Now we have the second subdivision. You have the first one, you need to divide this by the second one divided by the first one. You need to just find out whether it's the factor. So let us start. This comes to be 3x raised to 4 plus 5x cube minus 7x square plus 2x plus 2, and I need to write it in the proper order. This comes to be x square plus 3x plus 1. So the first term here comes to be 3x raised to 4 divided by x square. That is 3x square. So this is 3x raised to 4. Now 3x into 3x square comes to be 9x cube, and you have one 3x square. Okay, now changing the sign and then adding. So this comes to be 5 minus 9, that is minus 4x cube. This is minus 7 minus 3, that is minus 10x cube, 10x square, and bringing this 2x here. Okay, now I need to divide this. So minus 4x cube divided by 4x square, that is minus 4x is the next term that comes here. So this term is minus 4x cube. Next you have 3x into minus 4x, that is minus 12x square you get. Then you have 1 and minus 4x, so you get minus 4x. So the first term is going to be cancelled. You're going to change the sign now. 10x square plus 12x square comes to be 2x square. You have 2x plus 4x, that is 6x, and you have 2. Now I need to divide this by 2x square divided by x square. So I need to get 2 here. Okay, so this is 2x square. 3x into 2 is 6x. Then 1 into 2 is 2. Since up and down you have the same, if you subtract you get 0. That is 0, that means that you have the remainder is 0, that means this is the factor. This is the factor of this. Or I can write that p of x is equal to q of x into g of x. Q of x into g of x. That means since the remainder is 0, g of x is a factor of p of x. That's what we found out in the previous question also. Therefore x square plus 3x plus 1 is a factor of this given polynomial. Okay, you have the third subdivision of the second question. So I need to divide this one divided by this one, so that I need to check whether this is a factor of this polynomial. So for that I need to use the long division method. So this comes to be x raised to 5, and since x raised to 4 term is not there, I am writing it as 0 into x raised to 4. Then you have minus 4x cube plus x square plus 3x plus 1, and I need to divide that by x cube minus 3x plus 1. So this becomes x square because x raised to 5 divided by x cube is x square. So I need to write x 5 raised to 5 because x cube into x raised to x square is x raised to 5, and you have minus 3x into x square, that comes to be minus 3x cube, and you have 1 into x square, that is again x square. Okay, since these terms are same, this term and this term, they get cancelled. You get a 0 here, you get a 0 here. Now you have minus 4x cube plus 3x cube, that comes to be minus x cube, and you have 3x plus 1. So now you are going to get minus x cube divided by x cube, that is minus 1. So minus 1 you should write here. So now you get minus x cube because x cube into minus 1 is minus x cube. Then you have minus 3x into minus 1, that is plus 3x. Okay, then you have 1 into minus 1, that comes to be minus 1. So I need to change the sign now. This comes to be, this is going to get cancelled. Plus 3x minus 3x cancelled. Now 1 plus 1 is 2. This is not equal to 0. Since the remainder, that is r of x, is not equal to 0, the given polynomial, that is x cube minus 3x plus 1, is not a factor of the given bigger polynomial, that is x raised to 5 minus 4x cube plus x square plus 3x plus 1. That is what you infer from this. Okay. Next we'll move on to the third question. There was an example question just based on this. So this is a similar question. Okay. Okay, you have the third question. Third question is given a polynomial. You are asked to obtain all the zeros of this polynomial if root of 5 by 3 and minus root of 5 by 3 are two of the zeros of the given polynomial. Okay. So just by factor theorem, we had used that root 2 and minus root 2. Similarly, you have root of 5 by 3 and minus root of 5 by 3. So you can tell that x minus root of 5 by 3 and x minus root of 5 by 3 are factors of p of x. Let me name this as, this is p of x, okay? So these two are the factors. Just by factor theorem, if a is 0 of a polynomial, then x minus a is a factor of that polynomial. So this comes to be minus of minus, right? So I can just erase that and write for it to be plus. This is plus x plus root of 5 by 3. So you found out that these are two different factors. So you can just tell that the product of these two factors is also a factor of the given polynomial, that is x minus root of 5 by 3 into x plus root of 5 by 3 is factor of p of x. What is x minus root of 5 by 3 into x plus root of 5 by 3? That is a minus b into a plus b. That comes to be a square minus b square. Okay, it is a factor of p of x. Now we need to find the other factors of the given polynomial. So for that we need to use the long division method. So you have 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5. This is the given polynomial p of x, and you have x square minus 5 by 3 that you need to use here. So the first term comes to be 3x square here, 3x square, and you have so you need to multiply x square into 3x square, that comes to be 3x raised to 4, and you have minus 5 by 3 into 3x square. 3 and 3 is going to get cancelled. You get minus 5x square in the x square column, minus 5x square. So I need to change the sign. This becomes plus, this is cancelled. You have minus 2x square plus 5x square, that is 3x square again. Now you have 6x cube, I'm bringing it down, and you have 1 minus 10x. So that I get these two terms, okay, because it is x square and a constant term, so it will be going to these two terms now. So the next term comes to be 6x cube divided by x square. 6x cube divided by x square comes to be 6x. 6x is the next term. So I need to multiply x square into 6x, that is 6x cube, and minus 5 by 3 into 6x. 5 by 3 into 6x. So 3 and you get 2 here. So 5 into 2 is 10. 5 into 2 is 10. So you get a minus 10x. Minus 10x. So these two are going to get cancelled. No use of again changing the sign and adding, okay. Now you get 3x square minus 5. So for the next term, I need to divide 3x square divided by x square. The first term of this divided the first term of this, as every time I do. So you get a 3 here. You get 3. Okay, that is you get 3x square minus 5. Because minus 5 by 3 into 3 is minus 5. So you get a 0. You should get a 0 because it is a factor. Okay, the next part is to just write this p of x as a form of two factors. Now you have x square minus 5 by 3 with you, and you have one more factor, that is 3x square plus 6x plus 3. Okay, this is another factor. You have two factors for this. Since the remainder is 0, r of x comes to be 0. This is g of x into q of x. So you have this term. This term already we have found out that these two are the zeros, or it is already given in the question. Based on that only we got this factor. So we need to get the zeros from this factor only now. So we'll move on with that factor, that is 3x square plus 6x plus 3. 6x plus 3. For finding the factors, we always equate it to 0 and get an equation. So you have 3 common here. So I'll remove that 3. So it becomes 2x plus 1 is equal to 0. Okay. Now you have a square plus 2ab plus b square, or x plus 1 whole square as the x plus 1 whole square is equal to 0 as the factors of this given polynomial, that is x square plus 2x plus 1. So you have x plus 1 is equal to 0 and x plus 1 is equal to 0. Therefore x is equal to minus 1 and minus 1. So there are two similar zeros for this quadratic polynomial. Or I can tell that along with these two zeros, you have two more zeros. Therefore, zeros of p of x are minus 1, root of 5 by 3, and minus root of 5 by 3. This is the conclusion after getting all these things. Let me explain once more. This is finding the factors. For finding the factors, you need a factor theorem. You have the zeros to be minus root 5 by 3 and plus root 5 by 3. So you are using x minus a. So the product of them will also be a factor of the p of x. So you got the product and found out, and using the long division method, you are dividing this by quadratic polynomial by a quadratic. You get another factor from that as a quotient. That quotient you are going on finding the zeros, because this is already found out. We have that that is root of 5 by 3 and minus 5 by 3 and all. So you are going to use that. So for this you are going to factorize, but this was very simple because it is like a square plus 2ab plus b square term. So I could just write it directly over there. You get two similar of the zeros, that is minus 1 and minus 1. So the zeros of p of x come to be like this. Because it has maximum power to be 4, you need to write 4 zeros over here. Okay, moving on to the fourth question. We have the fourth question. The fourth question is given that this polynomial, that is x cube minus 3x square plus x plus 1, is divided by some other polynomial g of x. We are asked to find that polynomial g of x. If the quotient, I have written it to be q of x. Q of x is x minus 2, and r of x, that is the remainder, is minus 2x plus 4. Okay, now you are asked to find the g of x. So how we are going to do that? We have only the division algorithm. Again and again we are going to use the same thing. So let me consider this to be p of x, and you have g of x, q of x, r of x. I can just go on writing that. So p of x is equal to g of x into q of x plus r of x. Or this is only unknown. Remaining things I'll just substitute here. So this comes to be x cube minus 3x square plus x plus 2 is equal to g of x into, what is q of x? That is x minus 2. You have an r of x, that is minus 2x plus 4. So just I need to get this. This is the unknown. Generally when you have an equation like 2x plus 4 is equal to 0, you always bring all the remaining terms to the other side and get the value of x. That is what we are going to do here also. You have a expression, you need to get an expression here, not just a value. There is a difference between this and this. Okay, for this I'm going to bring this remainder to the left hand side. This comes to be x cube minus 3x square. You have an x term and a constant term. So I need to get this side. This becomes x minus of minus, that is plus. So it becomes plus 3x plus 2, and when it comes to the left hand side it becomes minus 4. So plus 2 minus 4 is minus 2, that is equal to g of x into x minus 2. Okay, now I need to divide this. For using the division, I need to use the long division method. Okay, long division. Is x cube minus 3x square plus 3x minus 2. Okay, then you have an x minus 2. Okay, the first term comes to be, here the more important is quotient, not the remainder. While you are checking the factor, you are always checking the remainder. What is the remainder? And the quotient was neglected. When you find out this thing, you need to get the remainder to be 0 because it is a factor. It needs to be a factor because there is no remainder in such a case. See, this is one polynomial and the remainder comes to be 0. So you need to get a remainder 0 here while dividing by x minus 2, and you will get the quotient. The quotient is more important here, not the remainder. Okay, now it comes to be x cube divided by x, so it is x square. So this is x cube, then minus 2 into x square is minus 2x square. Okay, I need to change the sign. This is plus, so this is getting cancelled. Minus 3x square plus 2x square is minus x square plus 3x. Okay, I need only two terms because two terms are here. So now minus x square divided by x comes to be minus x. So here I should write minus x square because that is x into minus x. Now minus 2 into minus x comes to be plus 2x. Okay, I need to change the sign. This comes to be minus. So 3x minus 2x is x, and you have x minus 2. Simple, x minus 2 and x minus 2. 1 times x minus 2, that is 0. Therefore, this is the coefficient. This we have found out to be g of x. Therefore, g of x is equal to x square minus x plus 1. This is the conclusion. Okay. The next question is all about giving examples. Okay, this is the fifth question. In the fifth question, you are just asked to give the examples such that you are asked to find p of x, g of x, q of x and r of x with the degrees. That is the condition here. Degree of p of x should be equal to the degree of q of x. So the condition for degree of p of x should be equal to the degree of q of x means that g of x should be some constant. Okay. So let me take some term, say 5x plus 7, and q of x, let it be 10x. Okay, let me take 2 times of this. 2 times of 5x plus 7 plus 0. 0 may be the remainder. That will be p of x. P of x is 10x plus 14. Okay, this is the example for this is p of x, this is q of x, this is g of x, and this is r of x. Okay, it can be any other example. If I can add one more number here and make this as 15 and remainder as 1 or anything it can be. So this is just a simple one. It's like you need to have the linear of this should be a linear and this should be linear, or the degree of this should be equal to this such that it should be divided by a constant term. Here I have divided by 2. The second part is degree of q of x is equal to degree of r of x. So you need to find out some terms such that degree of r of x and q of x should be equal, and by the meaning of division algorithm for polynomials itself, you know that the degree of r of x should be less than the degree of g of x. So let me take some example. Say x cube plus x square plus x. Okay, now I need to divide by some term. Say I'll divide by x square. I'll consider this to be g of x now. So if I divide by x square, okay, let me divide and see. X square plus x. If I divide by x square, I get a term that is x, and this comes to be x square, x cube plus x square, x cube, right? For x cube is first, then I'll get an x square, or in simple terms, instead of writing all these things, I can just tell that if I take x square common out of these two, I can tell that this is x plus 1. Okay, so this becomes q of x, and the remaining term is x because it cannot be divided by x square. So this comes to be x. This is r of x. You can find out that the maximum power of both of them is 1 only. Therefore, the degree of q of x is equal to the degree of r of x. Okay. Now, the third part is the degree of r of x should be 0. What is the meaning of degree of r of x should be 0? The second question was fully based on that the degree of r of x should be 0, and it should be entirely 0 over there. Here only the degree of r of x is 0. That means at last you can have a constant term 1, 2 or something like that. Any real number can be there, or it can be 0 also. So let me take something like this, x square plus 2x plus 2. Let me take this as p of x, and I'm going to divide it by x plus 1. This is q of x, and again 1 x plus 1 you are getting from there. That becomes g of x. So x plus 1, this is x plus 1 whole square, that is x square plus 2x plus 1. A plus b whole square is a square plus 2ab plus b square. So x plus 1 whole square comes to be x square plus 2x plus 1. So 1 is remaining over there. 1 comes to be the remainder. 1 is a remainder. The degree of this is 0. That means I can write it as x raised to 0. X raised to 0 is 1 itself. That's why the degree of that term comes to be 0. Okay.